On number 31, we're finding the value of the determinant, and we did number 30 using minor, so I said we do 31 using diagonals. So I still want the south, so 7 times 3 is 21, times negative 2 is negative 42. 4 times 6 is 24, times 5 is 120. And 5 times 1 is 5, times negative 1 is negative 5. So we got 73. Going north, I've got 3 times 5 would be 75. Negative 1 times 6 is 6, times 7 is 42. And negative 2 times 1 is negative 2, times negative 4 is 8. And if we do south minus north, 73 minus 125, we get negative 52. I'm going to go back to minors since I'm on a new video for part 2. So we've got 6 times the minor that is not under it. This sign I wish it changes, so this was positive 3, so it's minus 3 times the minor not under it, and then plus negative 2, so I just wrote minus 2 times the minor not under it. Okay, so we need to do the determinants. 2 times 0 is 0, minus negative 5, minus 3 times negative 4 times 0 is 0, minus negative 15, minus 2 times 4 minus negative 6. So I have 6 times 5 minus 3 times 15 minus 2 times 10. So 30 minus 45 minus 20 would be negative 35. The next section says use Cramer's rule to solve the system. The part on the test you're going to need Cramer's rule for is the setup. When I did these, I always like to do the easy part first, so that's the coefficients. So 9, 3, negative 1, 2. Where there was a in this case, we put the constants, and where there was a b, we put the b's. Since the setup's the important part, I'm going to go ahead and set up for b before we solve. Okay, the denominator, we already know it's the same, just the coefficients. And then coefficients of a, and where there were b's, constants. Okay, so when we do our determinants, we have the product of the south minus the product of the north, and product of the south minus the product of the north. And this is the exact same thing, so I'm just going to go ahead and add an 18 plus 3 is 21. And 9 times 12 is 108 minus 3. Okay, it makes you a little nervous when they don't come out even, but this is life. I think B is going to work better. We can reduce by 7, and 105 divided by 21 is 5. Okay, here's our setup again for x. Do the easy part first. 1, negative 205.6. In the numerator, where there were the x's, we put the constants, and then the y, and then the y's. Okay, for y, same denominator, and coefficients of x, and constants. Okay, do our determinants. 14 times 6 is 84 minus 4 times 5 is 20, and 6 minus negative 10. Again, I knew that's the same. 4 minus negative 28. So I've got 64 divided by 16 and 32 divided by 2. So x is 4 and y is 16. Okay, once again, here's our setup. I'm just going to go straight into this one. Negative 15, 19 are our constants. 4 and negative 7 are the coefficients of y over coefficients of x, coefficients of y. Coefficients of x, constants. For x, I've got 15 times 7 minus 19 times 4 over 3 times negative 7 minus 2 times 4. For y, 3 times 19 minus 2 times negative 15, negative 3 times negative 7 minus 2 times 4. X looks real nice. 105 minus 76 is 29. Negative 21 minus 8 is negative 29. Y at 87 over negative 29. So when we divide, we've got negative 1 and negative 3. Okay, last one with two variables. So we've got a equals 2, negative 1, 5, negative 4 over 8, negative 6, 5, negative 4. B equals, okay, where there was a B, I'm going to put the constants over coefficients of A, coefficients of B. For 37, I went ahead and wrote it down with zeros filled in for the missing coefficients. So once again, the denominator is just the coefficients of x, coefficients of y, coefficients of z. The numerator, where there was an x, I put the constants. And then coefficients of y, coefficients of z. And then the book says, use a calculator to calculate the determinant. Now on the test, they're just going to have you focusing on the setup for Cramer's rule, because obviously we can solve a system of equations using substitution or elimination too. The method's not important. So since it's multiple choice, they're going to say, hey, if you have the system, what would the solution for x look like set up in Cramer's rule? So I'm focusing on the setup with you. We're going to have coefficients of x. Where there was a y, we put our constants. And coefficients of z. Use a calculator to calculate the determinant. We already know the denominator is 440 because it was for the last time we did it with the same numbers. The new numerator, it comes out as 880, which reduces nicely. So for z, we're going to have coefficients of x, coefficients of y, and instead of z, we put the constants. And type it in the calculator, and it spits out nicely. So our ordered triple on this one is 1 to negative 1. To find a, we need first the constants, then coefficients of b, then the coefficients of c. Over the easy part, a, b, c. Type it in GeoGebra or calculator, and we get 6 over negative 12, which reduces to negative 1/2. So for B, we have coefficients of A. Where the B's were, we put the constants. And then coefficients of C. Type it in the calculator. And negative 12 divided by negative 12 is 1. Okay, for C, we've got coefficients of A, coefficients of B, and where the C's were, we put the constants. Type it in GeoGebra or graphing calculator, and we get the determinant of negative 72. And divided by negative 12, negative by negative is positive, we get 6. So our ordered triple is negative 1/2, 1, 6.